Hello everyone, welcome back to channel. So we have not recently posted any video on this channel, but this will be our first video after a long time. And now onwards, we'll try to post videos related to the engineering mechanics as the exams are approaching. So stay tuned with us. Those who are not subscribed to our channel, kindly subscribe it. So today we'll focus on a curvilinear motion. So first we'll go through the question. A curvilinear motion of a particle is defined by Vx is equal to 25 minus 8t meter per second and y is equal to 48 minus 3t square meter. At t is equal to 0, x is equal to 0. Find out the position, velocity and acceleration at t is equal to 4 seconds. So curvilinear related, rectangular component related question is asked. So here the equation of Vx, so velocity in x direction equation is given and the displacement equation is given. So we'll go through it. So this is the given question. Now we'll note down the given data. So first equation of Vx is given 25 minus 8t and the equation of y is given 48 minus 3t square. And conditions are given at t is equal to 0, displacements are equal to 0. Find the position, velocity, acceleration at t is equal to 4 seconds. So in this way, you have to write the given data and what findings are required that you have to mention. So it will be easy as to use the appropriate formula. So we'll start with the x direction. So we know that if velocity is given, we can approach in this way. If the displacement is given and you need to find out the velocity, then you need to differentiate it. And from velocity, if you differentiate, we get the acceleration. Similarly, if the acceleration is given, then you have to integrate it to get the velocity. Again, you need to integrate the velocity to get the displacement. So in this way, we should proceed. Okay. So to get the a value of displacement. As we know, velocity equation is given, so we should integrate the equation of velocity. So equation of velocity is 25 minus 8t. So integrate this equation. So after integration, we get 25 is a constant. So its integration will be t 25t minus 8t square divided by 2 plus constant. Now this t square divided by 2, it is multiplied by this factor 8. So 4t square plus c. So in this way we get the displacement equation. So after getting the displacement equation by integration, our task is to eliminate this constant. So to eliminate this constant, we'll put the boundary condition. So at t is equal to 0, the value of displacement is also 0. So we'll put it here 0, 25 into 0, 0, minus 4 into 0, 0, plus constant. So here we get the value of constant is equal to 0. Put it here and update this equation. So it becomes xt is equal to 25t minus 4t square. This constant is already 0. So this way we get the equation and at the end we need to find the value of displacement at t is equal to 4 seconds. So in this equation we'll put the value of t is equal to 4 seconds. So here we get 25 into 4 minus 4 into 4 square. So the answer is 36 meter. Kindly check the answer. Then we'll find out the displacement in the y direction is given equation yt is equal to 48 minus 3t square. So from this equation we'll try to find out what is the displacement after the 4 second. So in this equation we'll put the value of t is equal to 4. So here we get 48 minus 3 into t is equal to 4. So 4 square. So here the displacement after t is equal to 4 second is equal to 0 meter in the y direction. But this particle has a displacement in the x direction. So the position of the point after t is equal to 4 second will be x is 36 and y is equal to 0. Then we'll find out the velocity component. So first we'll start with the x direction. Now Vx equation is already given. So Vx is equal to 25 minus 8t. So at t is equal to 4 second, we can put the values here. So it is equal to 25 minus 8 into 4. So 8 into 4, 32. So minus 32 plus 25. So it should be minus 7 meter per second. Now we'll find out the y component velocity. So Vy. Now the direct values are not given, but the equation of yt is given. So displacement in the y direction is equal to 48 minus 3t square. As we have discussed, I'll just write it here. From displacement, if you want velocity and then acceleration, then you should differentiate the equation. So we'll differentiate this equation. So differentiation of y will be dy by dt, which is nothing but velocity. So differentiation of 48, it is a constant, so it becomes 0, and differentiation of minus 3 t square will be minus 3 into 2t. So minus 3 into 2 becomes 6, and it is 6t. Now put t is equal to 4 second, and we will get velocity in the y direction will be minus 24 meter per second. Now only finding the velocity in xy component is not sufficient. Find the magnitude of the velocity. It can be calculated by the formula v is equal to square root of vx square plus vy square. Put the values here. So we'll get the velocity 25 meter per second. So this way we can find out the magnitude of the velocity after finding vx and vy. Now our final task is to find out the acceleration component after t is equal to 4 seconds. Now in the x component, the velocity equation is given, right? So velocity is equal to 25 minus 8t. So what we need to do, whether we require to do differentiation or integration, kindly comment in the comment box. So velocity is given, so differentiation is required to get the value of acceleration. So it will be dvx by dt, which is nothing but acceleration. So ax is equal to differentiation of 25 is 0, differentiation of minus 8t will be 8. So it is minus 8 will be the acceleration. So the t factor is not present here. Okay, so it will be minus t and it is constant all over. So acceleration in the x direction will be minus 8 meter per second square. Now we'll find out acceleration in the y direction. Okay, we have already calculated the equation for Vy. It is nothing but minus 60. If we differentiate it again, we'll get the value of acceleration in the y component. So Ay is equal to differentiation of this minus 60. It will be minus 6. So acceleration after t is equal to 4 second in the y direction will be minus 6 meter per second square. And it is uniform acceleration in x and y component. Now find out the magnitude of acceleration. So it will be, formula will be same, square root of ax square plus ay square. So here we get the value of acceleration will be 10 meter per second square. Okay, so this way we are calculated. Just summarize answer for you. Position of the particle after 4 seconds will be x and y component, then velocity, these are the components, and this is the magnitude. For acceleration, these are the component in x and y direction, and this is the magnitude. Okay, this way you can calculate it very easily. Just remember, if the acceleration equation is given, from that you required velocity, and from the displacement you need to only do the integration. If displacement is given and velocity is required and the acceleration is required, do the differentiation, get the equation, put the boundary condition, will definitely get the answer. So I hope you like this video. If you have any doubt, you can put it in the comment box. Thank you very much for watching this video.